Moving on to question number 5, which is solve the following inequality. X square plus x plus 1 whole to the power of x is less than 1. So yeah, let's see how we go about it.
This question might seem to be a difficult one as it has exponent in terms of x. We'll just solve and see how we can make it easier. Whenever we have a question of such form, when we have the whole term in the form of an exponent which we can't solve, we simply take log on both sides to make our question easier. Now in this case, if we take log to both sides, we simply get x log of x square plus x plus 1, that will be less than log 1, and we know log of 1 is 0. That is, we get x into log of x square plus x plus 1 is less than 0. Now we can obviously get two cases. The first case, the first possibility, we have two cases, that is either x is greater than 0 and log of x square plus x plus 1, that will be less than 0. And the second case could be that x is less than 0 and log of x square plus x plus 1, that will be greater than 0.
Right. It's always better to divide the question into cases, such inequality questions, right?
Exactly. So first we consider the case x is greater than 0 and log of x square plus x plus 1 is less than 0. In this case, we have x square plus x plus 1, its log is always obviously less than 0, thus we have this term would be less than 1. That is, x into x plus 1 should be less than 0. That is, x should belong to minus 1 to 0 in open brackets. Now therefore we have the first case to be minus 1 0, in open dots it will belong between these, and obviously we have the second condition to be x greater than 0, that is this. So if we combine these two, we get null solution, that is the answer to this will be no solution
क्योंकि कुछ overlap नहीं होता.
Exactly. ऐसे केसेस में we just get the solution overlapping and we see इस केस में कि overlap करके x की कोई वैल्यू आ ही नहीं रही है, so this gives us no solution. So we come on to case 2. For case 2, we know that as log of x square plus x plus 1 is greater than 0, so we have x square plus x plus 1 should be greater than 1. Therefore, x into x plus 1 is obviously greater than 0. Thus, we get that x belongs to minus infinity से minus 1, open bracket में union 0 से infinity. So we have for this minus 1, 0, infinity and minus infinity. We get it something like this. Now combining the second result with it, that is x less than 0. For x less than 0, we have it to be this, this. If we find the common solution of these both conditions, we get it to be this area. So we see that value of x belongs to minus infinity to minus 1. That is, x is less than minus 1 being the answer to the question.
Okay, so in this question we saw the application of log. Now a very important property of log is the exponential property. That is, we saw that the x in the exponent comes in multiplication when we take the log.
Exactly.
So that is a very important property. And also another important thing is when you're trying to find the domain or the as in the
values
range for which the values of x for which a particular solution exists, you need to take into account all the cases. Like you should not forget the x is equals to x greater than 0 part also.
Exactly.
Otherwise it can lead to wrong solution.
And the more number of cases we break our question into, the simpler it gets.
Yeah, that was question number 5. Now we come to question number 6. It's a multiple correct choice question. Let a, b, c be 3 distinct real numbers such that each of the expressions ax square plus bx plus c, b and bx square plus cx plus a and cx square plus ax plus b are positive for all x belonging to R. Let alpha is equals to bc plus ca plus ab upon a square plus b square plus c square. Then we have 4 options. A, alpha is less than 4, b, alpha is less than 1, c, alpha is greater than 1 by 4, and d, alpha is greater than 1. So let's see how we solve this question.
In this question, as we can see, हमें दिख रहा है कि they have given us alpha in the form of a BC plus CA plus AB divided by A square plus B square plus C square. Now terms like A square, AB, CA, such terms we get only when we use the discriminant. Next we see we are given that these three expressions are positive for all x belongs to R. Positive means greater than 0. That is, their graph would be something like this. That is for all three of them. So we see that we first consider ax square plus bx plus c. We know that it is positive for all x belongs to R. So firstly we have its d would be less than 0 as the graph doesn't touch or intersect the x-axis at all. And secondly a should be greater than 0. That is, तभी हमारा ग्राफ concave upwards बन पाया है. तो फर्स्ट केस हमारा इसमें तीनों इक्वेशंस के लिए ही ये कंडीशन होल्ड करेगी. तो तीनों के डिस्क्रिमिनेंट्स अगर हम देखते हैं, दैट इज़ बी स्क्वायर माइनस 4ac इज़ लेस देन 0 और वी कुड से बी स्क्वायर इज़ लेस देन 4ac. ऐसे ही ये पहले एक्सप्रेशन के लिए था. दूसरे एक्सप्रेशन के लिए वी कैन ईजिली सी कि सी स्क्वायर वुड बी लेस देन 4ab एंड थर्ड केस के लिए ए स्क्वायर विल बी लेस देन 4bc.
ओके,
नाउ वी सी हमें ये तीनों तो मिल गए हैं. इफ़ यू जस्ट सिंपली एड 1, 2 and 3 वी गेट a square plus b square plus c square. This value will come to be less than 4 into ab plus bc plus ca.
और हमें ये एक्सप्रेशन देख के स्ट्राइक होना चाहिए.
एग्जैक्टली, वो हमने जो एक्सप्रेशन देखा उसके अकॉर्डिंग ही हम अपना क्वेश्चन सॉल्व करना शुरू करेंगे. सो एंड इन द एक्सप्रेशन वी आर गिवन दीज थ्री टर्म्स इन द डिनोमिनेटर. सो जस्ट शिफ्टिंग द टर्म्स वी गेट 1/4 इज लेस देन ab plus bc plus ca divided by a square plus b square plus c square and this our term is alpha. Therefore एक तो हमें ये मिल गया कि alpha is greater than 1/4 and अभी हम देखते हैं कि if alpha is greater than 1/4 then the possibility of each of the rest of the three options that is a, b and d is still open
because so, it's a multiple choice.
Exactly, क्योंकि alpha अगर 1/4 से बड़ा है तब भी वो 1 से छोटा या बड़ा हो सकता है और 4 से छोटा भी हो सकता है. तो इसलिए हम इसको ऑल सॉल्व करते हैं और चेक करते हैं. अब नाउ वी clearly know that a square plus b square plus c square minus bc plus ca plus ab. We know that this is equal to half into b minus c whole square plus c minus a whole square plus a minus b whole square. This being an identity. We need to be very thorough with the identities as they can be used in questions, especially in quadratic often. तो इसके बाद we know that this expression holds true, but we also know that the RHS of this, since it is entirely the sum of square terms, so it obviously has to be greater than 0 as a and a, b, c are also not equal. So we have half of b minus c whole square plus c minus a whole square plus a minus b whole square. This should be greater than 0. Therefore, as a result, we get that the term on the LHS side, that is a square plus b square plus c square minus ab plus bc plus ca. This will obviously be greater than 0. That is, we get that ab plus bc plus ca divided by a square plus b square plus c square. That will come out to be less than 1 and this again, as we know, it is alpha. Therefore the second thing case we get alpha is less than 1 and we also had alpha is greater than 1/4.
Okay.
Now as we have alpha is less than 1, that is our B option. We know कि अगर alpha 1 से छोटा है तो obviously the D option that is alpha 1 से बड़ा और A option that is alpha 4 से छोटा, obviously ये दोनों तो हो ही नहीं सकते. तो therefore the option to this question we get to be B and C.
Okay, the now answer
is B and C. Just a minute. Here the strike is, most of this I just said that A won't be the correct option, but actually no, A is also a correct option. We know कि अगर हमारा alpha 1/4 से बड़ा है, अगर alpha 1 से छोटा है, तो in that case alpha 4 से छोटा तो होगा ही. So B and C would be got by most of the students, but the A option, that is alpha less than 4, that also holds true here. And it is a multiple choice correct question. So the answer to this question is A, B and C.
Okay, so in this question we need to keep in mind, in multiple correct choice questions we need to check the validity of each of the options, because if you miss out on any of the options then we cannot afford to make such a mistake, right? So yeah, that was question number 6. Now we move on to question number 7, which says solve the given inequality. As we can see, this inequality looks very, very difficult to solve. But see, here multiplying everything, taking LCM, nothing will work. It will just complicate the question even further.
Exactly.
So we need to find some way of solving this question. Let's see how we will be going about it.
Before going to solve the question, let's just look at out a concept, okay, that we call basically if we are given a rational function of the form p by x of q by x, it is an any equality like greater than 0 or less than 0 or anything like that. Okay, so we solve it by the method of intervals. Okay, method of intervals, or it is also known as the wavy curve method.
Okay.
Wavy curve method, and it is a very useful method if we are given an expression which is of degree greater than 2 and we are given an inequality and we are to find the roots. Okay, so for this what we do, we are given this p and q. Okay, so first we just simply factorize p of x and q of x, p of x and q of x. We factorize these terms. Okay, after we factorize them, okay, we make the coefficient of x positive. Okay, coefficient of x, we make it positive. And thirdly, after that, all the factors, okay, we equate them to 0 one by one. Okay, equate them to 0 and we find the corresponding values of x. Those values we call the critical points. For example, if x minus alpha into x minus beta it is. Okay, so equating this to 0 we would get alpha, equating this to 0 we would get beta. So alpha and beta will be my critical points. So third step is finding the critical points. After that, once we have the critical points, we plot them on the number line. Okay, in their increasing order as we do plot a number line. And so we get that, suppose we plot them on the number line. So if we have n critical points, we can say it would be divided into n plus 1 region. Okay, plot the given points on number line. So for example, if there are 1, 2, 3 and 4 points, suppose alpha 1, alpha 2, alpha 3 and alpha 4, we see that the region would be divided into 5 areas. After this, what we do, in the rightmost region, okay, that is this region, the expression bears a positive sign. Okay, and if it is for greater than zeros. Okay, and in the other region the expression will bear an alternate sign. For example, if this is positive, this will be negative, this will be positive again, this negative and this positive again.
Okay.
So, and this not might be necessarily positive. We could take any value greater than alpha 4, any value, and we could just put it in place of x in our equation. If the value comes to be greater than 0, we put it positive or equal to 0. Then though it will be a root only. And if the value comes to be negative, we put here a minus. And if it is a minus, then the sign goes like minus plus and minus.
Okay.
So this is a wavy curve method, and this is the approach to whenever we are to do something with a rational expression.
And this is very important.
It is a very important
concept. Be practiced properly.
Because this is just an application of quadratic equations. When your expression is of a higher degree, we just factorize it and just follow this method. Now we are looking at a question. In this, we look at our equation first. Okay, that is a very big equation, and we can see that it has basically 8 terms. Okay, it is starting like this: 1 by x minus 1 by x plus 1 plus 1 by 2 plus x, and the sign also being alternative. So we could develop a symmetry. In our question. Okay, minus 1 by 4 plus x plus 1 by 5 plus x minus 1 by 6 plus x and plus 1 by 7 plus x, that is greater than 0.
So how should we go about thinking about this problem? Because it looks like a very complicated expression.
See, we could memorize this or whatever, that whenever our expression has so many terms, okay, obviously going with the basic rules of quadratic is not at all the solution. It would just waste time and won't give the answer. So that is the reason we give concepts like wavy curve method and other methods. They are actually they are to be used in such questions, and with practice only you get that you have to use such ideas in these questions.
Okay.
So in this we can see that we can't directly use the Vivi curve method. We need to modify it and simplify this big equation. As you can see the symmetry, and as you see that the sum of constant terms in the first and last expression, in the second and the second last expression, it's always 7. And also the coefficient of x, that sums to be 2. Okay, so we just combine the terms in this fashion. Okay, so we see that once we just add them together, so that way we see combining the first and last term, we get 2x plus 7 divided by x into x plus 7 minus 2x plus 7 divided by x plus 1 into x plus 6.
Okay.
Plus 2x plus 7 divided by x plus 2 into x plus 5.
Okay.
Minus 2x plus 7 divided by x plus 3 into x plus 4. See, symmetry is a very important is a very important thing in questions, okay, because most of the questions do follow some symmetrical pattern to be solved. So this is our final expression that we have. We take 2x plus 7 common out of these, okay, and we just combine the first two terms together and the last two terms together. Doing it that way, we get 2x plus 7 bracket 6 divided by x square plus 7x into x square plus 7x plus 6 and plus 2 divided by x square plus 7x plus 10 divided by x square plus 7x plus 12.
Why are we exactly combining two terms together?
We are combining the terms because at the end we need to reduce it to 2 or 3 terms so that we can solve it. We can't do anything with 7 terms.
Okay.
And we could do combining in any way, but that is what we look for, the easiest way that would be the least time consuming and would actually lead us to somewhere. That is and the first rule to look in the direction in which to go is symmetry. That is exactly what we did in this question. Okay, now in this question we see that x square plus 7x is the only thing common in these 4 expressions, and it is also in degree 2. So basically we could just let x square plus 7x, that is also x into x plus 7, we replace it by a term say t. Okay, replace it by a term say t. This way our equation will simplify to a great extent. So this way we have 2x plus 7. Every time if we have many bad expressions and if something is really common, we could just replace it by a simple variable to solve our question and later put its value. So if we replace it by t, we get 6 by t into t plus 6 plus 2 by t plus 10 into t plus 12 greater than 0. Now we are
getting closer to the quadratic form.
We simply factorize the term now. Okay, so we get it in the form 2x plus 7. Factorizing, basically we just take the brackets common and solve it. So we get it in the form 2x plus 7 into 4t square plus 72t plus 360 divided by t into t plus 6 into t plus 10 into t plus 12. One may think that getting such big numbers that we are maybe stepping wrong or in the wrong direction, or maybe it is not required, but you just need to keep patience till the end if you know that your method is correct. So we just solve it further to get 2x plus 7, taking some factors common, t square plus 18t plus 90 divided by t into t plus 6 into t plus 10 into t plus 12, that is greater than 0.
So we took out 4, but we can neglect it because it's an inequality and the other side is 0, right?
Exactly. And now coming to this term, okay, we know that t square plus 18t plus 90. The value of this discriminant for this quadratic, discriminant will always be, discriminant is less than 0, calculating b square minus 4ac. Okay, for all t greater than 0, therefore this value will always be greater than 0.
Because a is also greater than 0.
A is greater than 0 and discriminant is less than 0. These two are very important conditions and we need to keep checking them throughout our question.
Yeah.
So this value will always be greater than 0. So now we could just substitute the values of t that we first assumed. Okay, so that leads us to 2x plus 7 divided by x into x plus 1 into x plus 2 into x plus 3 into x plus 4 into x plus 5 into x plus 6, all the things basically, x plus 6 into x plus 7.
this should be greater than 0.
Exactly, this being greater than 0.
Now we can use the wavy curve method.
Exactly. Since we could actually see it in the form of factors. Okay,
Yeah.
so just plotting these numbers on the number line, we get -7, -6, -5, -4, -7/2, that comes from the numerator, -3, -2, -1 and 0.
Okay.
And the right term, as we see that any value greater than 0, be it 1 or anything, it would always be greater than 0. So this term we take to be positive, and then alternatively we allot the signs this way. Okay, so now wherever since our expression is greater than 0, so the regions where the sign is positive,
Will
our
be the
x would be belonging to those regions. Had this sign be less than 0, then we would have been including the regions where the sign was negative. So here, since it is greater than 0, therefore finally our x shall belong to -7 to -6 union, -5 to -4 union, -7/2 to -3 union, -2 to -1 union, 0 to infinity. Now we also see we have put an open bracket everywhere. I'm sorry, this is infinity, because we didn't have an equality. If we had it, if we would have an equality here, we would have put closed brackets on these regions.
Right.
So this was the answer of our question.
So in this question we see that we learned a new concept called the wavy curve method, which is very important from JEE point of view. So basically when you have very lengthy expressions, when you have powers of x much greater than 3, then, and if you see the possibility of factorization, if you can get an expression in terms of factors,
Exactly.
then it should be a clue to you to use the wavy curve method. And with practice you should become thorough with the wavy curve method. So yeah, that was question number 7.